Okay, we are going to begin by talking about the atom. The atom is the basic building block of everything that you see around you and even the things you don't see. We would define the atom as the smallest unit of an element, and we're going to define an element in a minute, but the smallest unit of an element that retains the properties of that element. So let me give you an example. If I have a chunk of gold, okay, that gold has certain properties. It has a certain melting point, a certain boiling point. It has a certain way it behaves when you put pressure on it, etc. And if I split that chunk of gold in half, both chunks will continue to behave just like the big chunk did. Okay, they retain the properties of the element even though I've changed the size of my piece of gold. And I can continue to break one of those pieces down, smaller and smaller and smaller, and it will still continue to retain those same properties. Okay, because I have at least one atom. Okay, and right down to a single atom, it will behave the way that that particular element, in this case gold, is supposed to behave. Now, if I start breaking it down beyond a single atom, then I'm going to start to see changes because it's no longer an element. It's a smaller thing, and its properties are going to start to change. So let's define an element. So um, matter that is made up of only one type of atom is what we consider to be an element. If I have only atoms of gold, I say that I have the element gold. If I were to mix any other type of atom in with that gold, even a single one, I no longer now have an element. I might have a mixture or a compound or a molecule, but I do not have an element unless there is only one type of atom there. Okay, so that's important to remember. Um, the gold, if you have any gold jewelry, there's a good chance that what you have is not actually pure gold. Okay, if you had pure gold jewelry, it would contain only gold atoms. However, we tend to make our jewelry out of a mixture of gold and other elements because one, it's cheaper, and two, gold itself is very, very soft and bendable, and we tend to not want our jewelry to be that way, so we mix it with other things. The periodic table of elements, that big giant chart that you see hanging in the back of the classroom, contains all of the known elements on Earth. There are a little over 100 on there, but only 90 of those can be found in nature. Okay, so there are certain ones that can be found in anywhere. They're considered naturally occurring. And there's about 90 of them. And then the other handful was created in a lab. They're man-made. They tend to be very short-lived. They fall apart very quickly after they've been created. And so they don't exist in nature at all. But there are a few of those on there as well. And on that periodic table, every single one of those elements that you see is represented by an atomic symbol. And that atomic symbol is very important because it represents only one element. Every symbol is different. Now, here are some guidelines as far as atomic symbols go, because you're going to be creating an atomic symbol for the Edmodo assignment, so you need to be aware of this. Atomic symbols are always a 1 or 2 letter representation. Okay, always 1 or 2 letters. Now you will see on the periodic table a couple that have 3 letters. An example of this would be UUQ. But those elements have not actually been officially named, and so those 3-letter symbols are actually just kind of holding their place until they are officially named. Those are not official symbols. 1 or 2 letters makes it official. And the first letter is always capitalized. Always. And if there is a second letter, that second letter is always going to be lowercase. And this seems kind of nitpicky, but it's very, very important when it comes to understanding what you're looking at. And let me give you an example of that. If I have the capital C little o, okay, this is the atomic symbol for cobalt. Okay, it represents cobalt and only cobalt. Now, if I do something as minor as changing that lowercase o to an uppercase O, I'm actually changing entirely what I'm presenting. Uppercase C stands for carbon. Uppercase O stands for oxygen. In the case of carbon and oxygen, neither of them have a second letter in their symbol. So this is carbon monoxide. Two very, very different things produced just simply by changing that one letter from a lowercase to an uppercase. Now, as you scan the periodic table, you're going to notice that there are some elements in which their symbol doesn't seem to have anything to do with the name of that element. For example, lead. Lead has the atomic symbol capital P, lowercase b. And you would think lead and PB, there's no relationship there. Well, that PB represents the Latin name for the element, and you'll see that periodically throughout the table. If you are scanning the table looking for mercury, chances are you're going to be looking for an M, and the letter M does not appear anywhere in the atomic symbol for mercury, which is Hg. So just be aware of that as you're looking for things. Some of them are going to be a little bit odd. Gold is Au, silver is Ag. There's just some oddities, and that has to do with Latin names. Okay, so let's talk about the atom, and I'm just going to give you just kind of a basic overview, and we're going to do some more with this in class tomorrow. The atom is made up of 3 subatomic particles. I'm going to guess you've heard of these subatomic particles at some point in your grade school career, but let's go over these real quick. Those 3 particles are the protons, the electrons, and the neutrons. And every atom that you see on that periodic table is made up of a different combination of these 3 subatomic particles. So by putting these 3 particles together in different quantities, you can change the type of atom that you have and the way that that atom is going to behave. And the protons and neutrons they're bound together. They're in the nucleus of the atom, or the center, and that term nucleus should be familiar to you because that's also the center of a cell. Okay, so you had that in biology last year, but the nucleus of the atom is made up of the protons and the neutrons, and we'll talk more about that in class tomorrow, and hopefully this helped to give you a little bit of overview, a little base to build the information on. Don't forget that you have an assignment on Edmodo that is due on Wednesday. You need to name an element, give it a symbol, and explain why you're naming it that, based on the criteria for naming an element that you read about in that article. Have a great night.